Hello, in this video I'm going to be showing you how to solve a basic Pythagoras 3D problem. In this problem over here we have a cuboid which is A, B, C, D, E, F, G, H. It's made up of these vertices. And it's saying for this cuboid the length AB to the length BC to the length of CF has the ratio 4:3. What we're being asked to do is calculate the size of the angle between A and F and the plane ABCD. We also have to give our answer correct to one decimal place. Now, how do we solve such a problem? So what we need to identify is the angle between AF, these vertices, and the plane ABCD. Okay, and what we've been given is the length of AB, which is 4, the length of BC, which is 2, and the length of CF, which is 3. And in this scenario, what we get is 3 right-angled triangles. And what we're trying to do is find the angle theta between A and F of this second right-angled triangle up here. Now, to get this angle theta, we are going to need to do opposite over adjacent. Okay, so tan theta is opposite over adjacent. So what we're looking for is the hypotenuse, the length of the hypotenuse identified by this green line over here. Okay, now if we know that AB is 4 and BC is equal to 2, right, we can use Pythagoras' theorem to get the length of this green line over here. Now, what is the length of this green line? Well, to get this length, we use Pythagoras' theorem, right? And that is a squared plus b squared is equal to c squared, where c is the hypotenuse. Now, if this is the case, right, then the hypotenuse c is going to be equal to the square root of a squared plus b squared. Okay, so using Pythagoras' theorem, right, what we get is the square root of 4 squared plus 2 squared for this green line over here. And that is the same as root 20, which can be simplified into root 4 times root 5, which is the same as 2 times root 5. Okay, so now we're ready to get the angle theta. This is because we have the opposite side and the adjacent side of this right-angled triangle over here, right, composed of the length AF. Okay, now that we've got this theta, we can say that tan theta is opposite over adjacent. And that is 3 over 2 root 5. Now, if we use the inverse function, that is arctan 3 over 2 root 5, we can isolate theta on its own. And it turns out that theta is going to be equal to 33.9 degrees to 1 decimal place. Okay, so you can check that on your calculator. You should get the result 33.85. and you round that to 1 decimal place, giving you 33.9 degrees. Okay, so this is how to solve a basic Pythagoras 3D problem. If you have any questions, leave them in the comment section and I'll try to respond. I don't often make problem-solving videos, but I think I might make more in the future. So if you're interested in these types of videos, make sure you are subscribed to my channel for more updates. For more maths content, check out mathematics.proofs on Instagram. Thanks for watching this video and see you next time.